All right, in the last lesson, we started looking at exponential growth and decay, which is where most of our exponent rules really come into play. In the first lesson, we talked about the zombie example, where if one zombie infects three other people, then those three each infect three, then each of those infect three, we get up to 27, then 81. So it continually grows at an exponential rate. So today I'm just going to give you the equation for exponential growth and decay. And this is the one we'll use for each question. So we use the formula P equals IB to the T, where P is simply the population size, I is the initial population, and B is the growth factor, and T is the amount of time. So in the last lesson, we looked at one example of population growth where the population started at 610,000, so that was the initial population. The growth factor was 1.029, and then T was the time after 1996. So let's get into an example for a population of wolves. So in a national park, a wolf population increased by a growth factor of 1.078 per year over a 10-year period, beginning in 1997. The formula P equals 124 times 1.078 to the power of n will model the population P after n years. So n we put in the number of years since 1997. And P will tell us the population for that year. So from our equation that we looked at, where I is our initial population, we can look at this equation and see that in 1997, our initial population was 124. So realistically, without doing any math for this first question, it says, what is the wolf population in 97? I can simply look at this, and this tells me my initial population is 124. But let's put it in the equation just to check. So we have our formula, 124 times 1.078 to the power of n. I sub 0 in for n since it is 1997. It's 0 years since 97. I know any base to the exponent 0 is going to be 1, so I just get 124 times 1, which equals 124. So we write our therefore statement, therefore the initial population is 124. So the next part asks us, what is the wolf population in 2007? So first off, this one we knew n was 97, n was 0 because 97 is 0, 0. Now each year after that goes 1, 2, 3, 4. So in order to find n, we take our year that we want to know and subtract the original year 97. So 2007 minus 1997 tells me that n will be 10. So now I take that 10 and I'll sub that into my equation for population. I sub that in, and we can calculate that by first doing the exponent, right? Just using our order of operations. I got 1.078 to the power of 10 is about 2.12. I'm going to multiply that now by 124, and we get 262.8, but we can't have 0.8 of a wolf, so we will round that up to 263. So therefore, the population after 10 years, or in the year 2007, is 263 wolves. In this next example, we are given a table. Okay, so this is telling me the light intensity that we'll get through depending on the number of glass sheets. Each glass sheet is 1 millimeter thick. So a sheet of translucent glass 1 millimeter thick reduces the intensity of the light passing through it. Light intensity is further reduced as more sheets of glass are placed together. So when there's 0 sheets of glass, obviously 100% of the light gets through. If there's 1 sheet of glass, 89.1% gets through, 2, 79.4, 3, 70.7. So we're just going to answer these questions given our table here. So what is the light intensity reduction rate of a single sheet of glass? So right here I have my single sheet. The light intensity is 89.1%. How many sheets of glass are needed to reduce the light intensity by 1/2? So reducing it from 100 to 1/2 of 100, we know half of 100 is 50. So to get it down to 50%, we would need 6 sheets of glass. Okay, and next part is to just graph it. So here we have our graph. I'm going to take each point. So 0 will be my x value, 100 my y value, and I get a point right there, 0, 100. Next point is 189.1, which will be just below 90, right about there. And then our next one, so for 1 sheet of glass, 2 sheets of glass, 3 sheets of glass, 4 sheets of glass. You can see it almost looks linear when we only have a few, but as we continue on, plotting each of these points up to 8, which we were given, we can see there is a slight bend here. Okay, so we've graphed it. And now use the graph to determine how many sheets of glass are needed to reduce the light intensity to about 25%. So we want to know when the light intensity will be 25%, which is along here. So we don't have the values for 9 sheets of glass or 10 sheets of glass yet. They weren't given to us. So there's 2 ways we can do this. One way is to simply continue the trend. Okay, so put a line and just the best you can keep that same curve going. Okay, and then we can look at this line to see when it's at 25%, which is at about 12 sheets of glass. Okay, or to be more accurate, what we can do actually is we could write out our equation. Okay, so we know if we use the population one, which is similar in this case. So this is I. My growth rate, number of sheets. So I want my light intensity to be 25. So I want this to be 25. My initial value, we know when there's 0, so my initial is 100%. So my initial value is 100. This rate, we don't really know. Okay, so my rate is sort of unknown, but I can tell by looking at this that if I divide 100, remember using our ratios, if I go 100 divided by 89.1, oh, sorry, I did that backwards. It should be the one after divided by the one before. So 89.1 divided by 100 gives me approximately 0.89. If I do the same thing with this one now, 79.4 divided by 89.1, we'll get the same thing, or approximately the same thing. Since these numbers are rounded, it'll be a little different. So I'm just doing my ratios, and again, I got 0.891. If I continue doing that, I will get 0.891 for each of these, or approximately that. So that tells me that my rate here is 0.891 to the power of n. And now to check where we said we thought it was 12. We said it was 12 when it's at about 25%. we can check to see. Okay, so if I sub 12 in for n, 0.891, and then I sub 12 in for n, if I calculate that, 0.891 to the power of 12 gives me about 0.25 times 100, we get 25. So therefore, 12 sheets of glass are needed to reduce the light intensity to 25%. Okay, so that's exponential growth and decay. Just remember that it will be growth if our rate here is between zero, sorry, it'll be growth if it's above 1. It will be decay if it's below 1. Okay, so if you want to start on your homework, there are the questions from the textbook that you can work on. You'll also have some time in class to do them.